Hello everyone, it's me Samiksha, one of the ccna ccnpr and trainer of Network Alliance damak. Today I'm going to discuss about the IP addresses. IP address is a logical identification to each of the computer network devices that helps to make the communication using the internet protocols. So let me go through here. First of all, you have a certain devices, okay? Let me suppose you have a desktop, you may have a wireless connection also, you may have a laptop too, okay? And you may have the smartphone as well, no problem for that. And you connect your desktop to a switch, and there is a router, normally broadband router, or what we can say, it has both features, wired and wireless. So it is also getting the wireless network as well as you are getting the wired network, okay? So after that you get a connection, okay, internet connection from your nearby ISP, and furthermore, and there are the different other services, okay? ISP is there, and let me suppose you want to use a certain feature of your Google, okay? Certain you want to watch the certain videos of your YouTube and many other resources, okay? So whenever, although we use the various services, first of all, like this is a physical structure, okay? This is a physical connection. So over the physical connection, only the physical connection is not enough to make the communication from a particular source, okay, from a particular source to a particular destination. Why? Because they must have an addresses, okay? They must have an identification so that they would be recognized and easily source and destination can communicate. That means if you are sending a request to your destination, then that request must be reached to your exact destination. So for that case, each of the devices, okay, each of the network devices are assigned with a IP address. That is a logical address, okay? Physically you have a structure, and physically each of the devices will have a physical address known as a MAC address, but the vital role is played by your IP address for its logical identification. IP address is a like numeric value, or what you can say, okay? It depends upon the its types, and each of the devices must have to be assigned with an IP address. That means each of the devices should have addresses so that it can reach to a destination, and destination can easily reply back to the exact source. So let me suppose you may have your like mobile phone, and it may have a particular number, okay, so that you can call to your friend, okay, and you will be you will be recognized by that. Similarly, IP address is categorized into two types. We talk about the both of them. One is ipv4 address, another is the ipv6 address, okay? It is IP version 4 and it is IP version 6. So let me go through here, like this all the IP manipulation, okay? IP manipulation is done by the IANA. IANA is one of the public domain, the public organization which works over here for the IP manipulation. You may know that like we have the two networks, okay? Two networks means we have a physical network first, okay? The physical, or what you can say, a private network. First of all, you have a private network, or the local network, you can call it as a local network also, local area network also, and you have the another network called the WAN. So each of the IP addresses, each of the IP versions have categorized it, or they have divided its IP addresses on the basis of the lane, or what to use on the lane side or the private side, and what to use on the WAN side. So, and another thing is that we will talk about the IPv4 address first. So IPv4 address is categorized into various classes, okay, and it has a certain range, or the what type of IP address you can use on your device, and what is not allowed to use, or the what are reserved. So let us go and check it out, which devices can use the which type of IP addresses. So let me go through here. we talk about it, we have the two type of addresses. One is IP version 4 and another is the IP version 6. IP version 4, okay, Internet Protocol version 4 is a 32-bit addresses. Okay, 32-bit means, let me suppose 32-bit means it is a like, let me write a IP address like 192.168.1.10. okay, you may have seen these addresses, like this is the format of a ipv4 addresses. Like each of the addresses or each of the segment, it divided into 4. okay, you can see over here 4 of the segment is here. And another thing, each segment, okay, each segment contain 8-bit, that is a octet. You can call it as a octet also or 8-bit also. okay, we are talking about the IPv4 address. So altogether you have the 32-bit addresses. okay, 32-bit in total addresses. That means we normally know the decimal format, but here the computer understand about the binary format. So whenever we go to the like decimal format, then we are going to have 2 to the power 32 addresses worldwidely. okay, that is total addresses that we are going to receive, or total number of devices that can assign the IP address is 2 to the power 32 addresses. And this is the one of the format of your IPv4 address. It is written, one of the number will be written over here and a dotted sign will be there, and another dotted sign, that means it is separated by the dotted sign. okay, dotted point. And you may be curious that how much number we can assign over here on the each of the segment. okay, that is only the 8-bit. you can assign the value up to 8-bit. that is how much addresses you can assign, 2 to the power 8, because this will hold only the 8-bit addresses. On decimal, because we write in the decimal format, so we should know 2 to the power 8, that is a 256 number you can assign over here. But the number will start from 0 and will and if you count from the 0, then 255 will be 256 will reach from the 255. So in each of the segment you are only allowed to write 0 to 255 and then again 0 to 255 values. okay, and then again 0 to 255 values, and then 0 to 255 values in each of the 4 octets. Again, you are not allowed to write some of the IP addresses or the IPv4 addresses. So let us go and find it out. okay, so here it's a 32-bit addresses and its format is written like this one, and one of the X, okay, one of the segment contain the value of 0 to 255, and total addresses we are going to have is 2 to the power 32 addresses. And already told that it is separated by the dotted sign, okay, like this one in each of the segment, and it is divided into 32-bit addresses is divided into 4 of the octets. okay, 8-bit, 8-bit and 8-bit and 8-bit. that means it only holds 8-bit means 8-bit means 1 2 3 4 5 6 7 8. okay, 8-bit total 0 to 1 2 3 4 5 6 7 8. okay, total 8-bit, this much to this much. okay, that means it will hold a value up to 8-bit, and that we know that it hold the value up to 0 to 255 while we will write in the decimal format. So here are the some of the classes assigned, or the classes are categorized in IPv4 address. First is like there is a altogether class A, class B, class C, class D and class C. I already said that we had the addresses from 0 to 255. okay, we had the addresses from 0 to 255. So from 0 to 255 is also categorized into each of the 5 classes. So any of the addresses, okay, just like we see a addresses that 192.168.1.1 like that on. If any of the addresses that start from the 1 and 2, 3, 4 and so on to 126, then it will belong to the class A addresses. And if any of the addresses that start from the 128 and ends with the 191, that means 128, 129 and so on to 191, then it will be belonging to the class B addresses. Similarly, 192 to 223 will belong to the class C addresses, and similarly 224 to 239 will belong to the class D addresses, and finally class E addresses 240 to 54. Okay, we use the many addresses, but among that class D and E are not allowed to use, okay, because D is reserved by the multicast addresses, and we as a normal user we cannot assign in our devices, but the ISP use it for the multicast purpose. And for class E addresses we are not allowed it to use because it is used for the research and deployment, or just you can say it for the experimental purposes. So the second thing is that we know about the range. Okay, in class A addresses you can also say that here it belongs from 0 to 127, but normally this is a valid addresses. Why? Because if any of the addresses that start with the 0, okay, any of the addresses if that start with the 0, then it is known as a global addresses that we cannot assign in our device. Okay, that means our devices will not support this address, you can call it that. And another is the 127 addresses. This is a self-communicating, or what you can say, it will reply back to your device, and this is a loop back addresses. And if any of the addresses that start from the 127, we will not going to use it. So let me check it out. Let me show you first. I have opened in a packet tracer. I have the some of the devices I want to use here. Okay, IP configuration. I want to use the addresses that start with the 0. I want to use the 100.100.10.110. Okay, so you can clearly say that this is an invalid IP addresses and that you can't use. Okay, and another 127 addresses, it is a self-assigning addresses. Okay, let me go over here. Let me check it out. IP config. IP config means show me the IP configuration. It will show you the addresses that is assigned to your device. So you can see I have addresses, ipv4 addresses, that is 192.168.10.105. But whenever I ping to the 127.0.0.1 or any of the addresses that start with the 127, then you can see that it is giving me a reply back. Why? Because this addresses is the self-communicating, or the self, it will reply you the back. Okay, so this is a loop back addresses. So let me go over here. Let me jump to the prefix bit. What I mean by prefix bit is that, let me give you an example. You have organization, okay? You have organization, and you have a switch, and another switch is also there, and you connect the devices. You have a devices, okay? Let me suppose you have the 100 devices, 100 computers, or any of the device, laptop, okay, smartphone. And we know that to make a communication to the internet, we obviously require a IP address. So for that case, that means you have the 100 devices, means you require 100 IP addresses. But which of the addresses, which of the classes is to be assigned to this network, or what IP can be assigned on the first device, and what IP can you assign on the second device, what IP can you assign on the third device, and so on. So this is all categorized by your related prefix bit. Okay, prefix bit is, that means prefix bit will help you to find out in this network what will be the network. Okay, in this particular your organization network, what will be the network of your IP, and how much user can be assigned to that addresses. That means how much host you can receive from that. So it is categorized, or you can find out through the use of prefix bit. Okay, that means let me give you a proper example. Like here you have assigned addresses 10.1.1.1, and you may be thinking what IP can I use on the second devices to make the communication to the first one? Okay, so that problem is solved by the prefix bit. This is the like in the binary format we call it as a prefix bit or the subnet length, and in our decimal format we called it as a subnet max. So in the second device, either we are planning to use the like 11.1.1.1, will two of these addresses will able to make the communication here, or you just have to assign the addresses like 10.1.1.2 or so on. So let me go over here and show you, okay, which of the addresses you can assign. So let me go over here. Prefix bit means the like if any of the addresses is of 1 to 126, then it belongs to the it holds the 8 bit. The first octet bit is held as a prefix bit by the class A addresses, and class B addresses it holds the 16 bit, class C addresses it holds the 24 bit, and for the subnet max, okay, because we already knew that 8 bit is a 255, so subnet max is 255.0.0.0, and class B address is 255.255 because it holds the 2 octets, that is a 16 bit, okay, and class C will hold the 255.255.255.0 because it holds the 24 bit as its network. So you can clearly see over here that network can host that it is a 8 bit, okay, 8 bit has been completely fulfilled. Like this one, let me go over here, let me show you. If it is a class, then what do you know? It holds the 8 bit, that is first 8 bit has been occupied, that is 8 bit means 1 2 3 4 5 6 7 8, 8 bit has been occupied, and remaining order, okay, because our addresses is of 32 bit, so remaining order are, you can assign the value over here, but this first octet has been completed, okay, because in binary you know that we only have the 0 to 1, so this 8 bit has been occupied, so you can assign the other value, you can make a change, okay, on the other octet, that is 8 bit has been your network, it is noted as a network, okay, and other are your host, okay. So this means that if you pick up the address from the A class means which address? 1 to 126 addresses. So any of the addresses you can pick, like I want to pick up the 100, okay, I want to pick up the 10, okay, 10.0.0.0, and it's of 8 bit, okay, it's of 8 bit because we already said that it belongs to the A class, so it holds the 8 bit as a subnet bit. So in this, so let us just go over here, we have one of the device over here, and another device and another device. So if you want to assign the IP address on this single network, on this LAN network, and make a communication between the different devices, then you are planning to use a certain IP, obviously, okay. So in the first, what you assign? 10.0.0.1, okay, this is the address that we assign on the first device, okay. On the second device, what you have to assign, because 8 bit has been completed, that is you have one of the 8 bit is your network bit and remaining other is your host, so that the network to make a communication in a single network, okay, your network must be the same, your network bit must be the same, and your host should be different, okay, at least your host should be different, but your network must be same. So on the second, because we know that it is a 8 bit, so first octet is your network and remaining other is your host. So on the second, your network must be same, 10 must be same, and host can be different, okay. Different means what value you can assign over here? You can assign the value up to 255. So I just assign the 10.100.1.10. So these two devices will be able to make the communication. But what about if I use addresses, or if I make a change on the third, that is I want to assign the 11, okay, 11 and 1.1.10 on the third device, then this device will not be able to make the communication with these two. Why? Because its network bit is different, and that is done by your prefix bit. That means the prefix bit noted that it is a 8 bit addresses, so your first network is to be same to make a communication within a same network. So what about if you have the another network over here? Okay, suppose this is a company A, and inside this company A network you are planning to use the 10 addresses, and in the B company B you are planning to use the different addresses. Okay, so for this, for a single network we are going to use this all the addresses, and for the another you must have the different network. Okay, so here you can assign the addresses like any other addresses, like you can assign the 192.168. like 1.10, okay, 1.10 addresses over here, 1.10, 1.11, like 1.11, 1.12, and so on. That means this is a different network and this is a different network, but you cannot use the 11 over here. Why? Because these devices will not able to make the communication between the two, because this is a single network and there is no any such devices we can make a communication between the different network. So always remember that to make a communication in a single network you must have addresses that has the network bit as a same. Okay, so let me check it out. Like another thing we have to be careful. So if you are assigning the A class addresses, then how much devices can you assign on this? Okay, you assign the 10.0.0.1 on the first device, on the second like 100.110, okay, 100.110 on the third devices, on fourth devices, on the fifth devices, and so on. Okay, so how much devices you are going to have is that you are going to have, this is the first bit is been occupied by your network bit, and the remaining other is your host, and host you can make a change. So that means host it 8 bit, 8 bit, and 8 bit total. How much bit? That is your host is altogether 24 bit. So here on this network you are going to have the 2 to the power 24 addresses, or the 24 2 to the power 24 devices in this network if you had such devices, or okay, if you have that much of devices then. So this is what your particular prefix bit will determine. But again, okay, what I'm going to write is that we are going to write in a decimal format. So this is your IP, this is your IP, and we are going to write a certain subnet max, okay, subnet max, and here the subnet max will be 255 because it's a 8 bit, okay, don't forget that it is a 8 bit, and even is your host bit. So for the 8 bit into the decimal format we are going to write the 255.0.0.0. Okay, on the second device we also have the same subnet, third is also going to have the same subnet, fourth up to 2 to the power 24 addresses you can assign on this single network. And to make a different network, your network bit must be different, okay, not to the same. Your network bit must be always different. So let me check it out. Let me show you the same thing over here. That is, if you want to make communication between the two devices like this and this, then their IP address must have a same network bit. So here 10.1.1.10 I assign this, and you can see that subnet max is 255.0.0.0, and on the second device also I'm going to use the, I want to use the different network. Okay, first of all I'll show you 192.168.10.1, and it gives the subnet max of this much. Okay, we'll talk it about later. So let me go and check it out whether these two devices will make a communication or not. 192.168.10.1. Yes, we have to wait for it. Its 4 packet will be going. No, it's not making a communication because first packet says that the request timeout. Second is also said that the request timeout. But still, let us wait for the third and fourth also. Okay, third is also a request timeout. And finally, the last packet. Yes, you can see that it's a 100% loss. Why? Because we clearly know that it has a 10. Okay, it has only a single network, that is a 10.1.1.1. It belongs to the class A addresses, and this belongs to the class C addresses. And another thing is that they have the, like, it has only a single network. Okay, only a single network 10. The 10 must be same on the second device, but here what happened is that your network is completely different. So the two different network cannot make a communication. So let me go over here. I'm going to use the now same type of addresses like 10.1.1.100. Okay, 10 network bit is the same now. The first device's and second device's network bit is same. So let me make a communication from here. Okay, let me ping to the 100. Yes, you can see that both of the devices are making a communication. So I hope you now understand that what was the role of the particular prefix. So here on the class A addresses, it is going to assign the 8-bit. Class B addresses, that is going to assign the 16-bit. Okay, so for the class 16-bit means what? 8-bit and 8-bit. Okay, 255.255. And here you can clearly see that if it is a 16-bit, then it is going to have the 2 of the bit as your network bit and remaining 2 is your host bit. So let me pick any of the addresses from the class B. Okay, 128 to 191. So I want to pick the addresses like 172. Okay, 172.16.0.0 and it's of 16-bit. And also it belongs to the class B. Why? Because in class B 128 to 191. Okay, this range belongs to the class B, so 172 belong over here, so it belongs to the class B. And in class B, if it is a class B, then it is going to be a 16-bit addresses. 16-bit means first 8-bit is completed and second 8-bit is completed and remaining other are left. Okay, so this is a bit, this is a format on the bit, but what we write is that we write in the, or like you can also write like this, 8-bit is completed, 16-bit is completed. Yeah, so 1 2 3 4 5 6 7 8, 8-bit is completed and remaining other is left for the network, host. Okay, so 2 of your is your network and 2 of your is your host. So if you are going to have if you are going to have the devices over here on your network and planning to use this B class address, then what you have to do is that first devices you assign the IP 172.16.0.10. okay, on this first devices, and it's of how much bit? 16 bit. Okay, so you are going to have a subnet max how much? 255.255.0.0. Why? Because it's of 16-bit. okay, so we have to write on the decimal format, and in decimal format we are going to write the 255.255. This is for the first devices. So if you are planning to use the planning to make a communication in this network, then what you have to do is that your 2 network bit must be same over here. 2 network bit means this first and the second must be same over here. Why? Because it is a 16-bit and so on. So 172.16 must be same. You can make a change on the host bit. Okay, but you cannot write the 0.10 here also, otherwise it will duplicate. Okay, because both of the devices gonna have the same address, so they will be confused to whom they should make the communication, so both of the devices will stop working. So here I can write 0.102. yes, I make the change on the host bit. So these devices is gonna make a communication right now. So on the third, subnet max is same. Okay, subnet max is same. So on the third device, what are you going to use? Your network must be same. Network means 172.16 must be same, and you can write the any 0.111 or anything. But never thought that here are the 2 network bit. Okay, that is a 16 network bit. So 172.17. If you write like this one, then they are not going to make a communication with these addresses, like the 0.1. okay, I write this, then it is not going to. Let me suppose there is a device and you assign this IP, then what will happen? These devices will not able to make the communication to this one. Why? Because it is also off. Okay, why? Because its network 16 is here and 17 is here. Okay, that means their network bit are different, so they will not able to make the communication. So be assured that if you are assigning or whatever network you are going to assign, that network bit must be same, that host bit must be same, and the host should be different to make a communication in a network, and that is categorized already by the standard format of classes. So B class is also completed. Okay, so and for the C class addresses, what will happen is that if you have the any addresses, if you are planning to use the any addresses that belongs to the C class, that is 192 to 223 range. Okay, then it occupy the 24 bit. That means 3 of the octet is completed, That means on the network and host, three of the octets is your network and only the one is your host. Okay, so that means let me pick up the addresses like 192 from the 192. Okay, 192.168. Suppose 10.0 and it's of 24 bit. Why? Because it belongs to the C class addresses. Then it is going to have the how much subnet? 24 bit means 255.255.255.0. okay, that means on the network and segment third octet, up to third octet there is a network bit and only one is your host. That means let me suppose you have devices over here connected like this one on the same basis, and you are planning to use this address on a first one device. Then okay, on the first device what we use is that 192.168. suppose 10.100. you assign this IP on this one. Okay, and subnet is the same. Okay, subnet is this one. Then on the second device what you have to use is that, because it has a 3 network, yeah, because it's of 24 bit, so here the third up to third octet it must be same. Okay, 192.168.10 must be same. Why? It will represent that it belongs to the same network. Otherwise, if you make a change like this one, okay, 111, right? If you make a change like this one, that 192.168 is same, but in place of 10, what you write? You write 9 and like 10, okay, and 102, okay, anything. Then what will happen is that your network, okay, network bit are not same. 192.168.9, 192.168.10. Your network bit are not same. So the third devices is never gonna make a communication with these of the two. Why? Because they belong to the different network. It belong to the different network. So always think that to make a communication in a single network, your network ID must be same and the host should be different. So here, how much host you are going to have? Okay, if you are planning to use these all the addresses from the C class addresses, then how much host you are going to have? 24 bit is completely network, so you cannot make a change. You can make a change only up to the last bit only. Last bit means 8 bit only, last 8 bit only. Okay, because total is 32, so last 8 bit only. That means 2 to the power 2, 8. Okay, 8. Yes, 8 is your host. That is how much addresses? 256. But we never use the two of the addresses. Okay, the very first address on this one, that is, we don't use 192.168.10.0 because it is noted as a network ID. Okay, network ID, so we don't use this. And another is like 192.168.10.255. okay, and this is we noted as a broadcast IP for this network. Okay, broadcast IP for this network, so we don't use these two addresses. Okay, we don't use the two addresses, but in between them, like 10.1, 10.2 to 10.254, we use that addresses. So that means how much addresses you can, if you have organization, okay, if you have organization, then how much addresses you are going to have is that if you assign these addresses, okay, then you can assign up to 254 devices over here. Okay, not more than that. That means if you have the devices like 500 devices you have, okay, 500 computers you have, then you cannot use the B class, C class addresses. Why? Because each range only give you the 254. That means you cannot assign the different network also, because this is a single network. Okay, single network. So we can see over here we cannot make a change, and we already see in the A class also we cannot make a communication between the different network. So we have to use the same network. And if our host is like that sound, okay, then which addresses you can use? Either you can use the B class addresses, either you can use the A class addresses. That is, whenever you have, so first of all you have to go to the classes and you have to go to the possible host, how much host you can have. Okay, and then always we write the subnet max also. So like this on IPv4 address is classified into the class A, class B, class C, class D and class E addresses, and we talk about the subnet max and we can assign these addresses. And here last time I said that we have a private network and we have the public network. Okay, so we have the private network means, let me suppose this is your ISP. Okay, this is your internet service provider. It provides the network connection to the various clients. Okay, various clients. Okay, this is a client 1 and another client is also there, another client is also there, and like this on to the various clients. Okay, so each of the client, each of the topical network will have, like, what will happen, it has a private network, I already said, and it has a public network. Okay, public is normally we can say as a WAN, and private is normally we call it as a LAN. So in LAN network you are going to have a certain addresses only. Okay, you cannot use the other, and in public network there are the certain addresses you can use. And for the public addresses we always ask for the ISP, or the ISP perform that, and ISP has also get a certain range of IP from the INR registry. Okay, and there are the INR registry, and you have to get a IP from the related registry on a list for a certain time, and that is done by your ISP, so you don't have to go for that. But as per the ISP, they will get a certain range of addresses from your related INR registry and will assign to you. So public addresses is different, private addresses is different. Okay, so what of the addresses you are going to use in your private is any of the address that start from the 10. Okay, 10.0.02, 10.255.255.255. Why? Because it belongs to the A class, and 172.16 to 172.31. Okay, and 191.168 to 191.168. 255. So this mode of addresses are you are going to use in the private network. Okay, in your network, and this, and except this, and except the reserved IP. Okay, except the D and E class, except the private IP, and except the 0 and 127, we are going to use on the public network. Okay, in a public network. And one more thing, that the last address, one address is left over here, that is up to 254 is also only over here. Okay, so one of the addresses we are not going to use, that is 255.255. Okay, any addresses that start from the 255 we are not going to use. Why? Because it is noted as a broadcast address, so that is also reserved. Okay, so you can write over here also 255. So this is how the IPv4 addresses has been classified. So you can use any of the addresses. Like if I use the 1 and 2 addresses, okay, if I go for the C class, then what I have to do, 192.168.10.1. if I assign this, then if I want to make the communication, I assign these addresses on this first PC. Now what is this? 192.168.10.1. it belongs to the C class. It's of 24 bit, that is, it has a 3 network bit, 3 network segment, and 1 is your host. So if I am planning to make a communication to this device on a LAN network, okay, so what IP can I use? I have to be sure that my network bit are same with this one. So network bit is 192 must be same, 168 must be same, 10 must be same, and host should be different. You can use the any of the host, like 10.10. Okay, so let me show you the another thing also, that I have said we cannot use the addresses like 192.168.10.0. I cannot use this on the very first address because this is a network ID, and I cannot use the another address, last address is 255, because it's a invalid. So that's why I did the -2. Okay, that was the case. So I can use the any of the addresses over here, 10.254, and it's similar to this one. So subnet max is here, you can see 10.1, and network bit is same. Okay, so let me go over here, let you have a look. Okay, yes, 192 is same, 168 is same, 10 is same, because it has a 3 octet must be same, because it's a 24-bit address, and your host is different, so these two devices will make a communication. So let us have a look from here. Let us have a look from here, from the command prompt. I want to ping to the 192.168.10.254 and check it out whether they can able to make a communication. Yes, you can see that they are making the communication. Hope you understand. So this is how we assign the addresses. So let me give you the only hints for what's the difference between the IPv4 and IPv6. Just only that much only. Okay, because we see on the IPv4 address we only get the range of 2 to the power 32 addresses in total, and also we see that there are the certain reservations also. Okay, certain IP address you cannot use it from the IPv4 address, but so in order to fulfill the range of our and another thing is that each of the devices should use the unique addresses. Okay, not the same, unique addresses, they must have a unique addresses, and to make a communication to the internet. Okay, to the various network. So for that purpose, obviously we are not being able to, like, this IPv4 address is not able to fulfill the demand of the addresses that are required to edge and devices in today's world. Okay, so they launched the IPv6 addresses, which is of 128-bit address. Okay, 128-bit addresses, that means we are going to have the 2 to the power 128 addresses. So it is a very large huge range, okay, huge number of addresses that we are going to have from IPv6 addresses. So till now both of the addresses are being used, okay, slowly, and also we'll talk about the IPv6 addresses also later on. So this is the difference why IPv6 address has been launched. Just one of the major reason is that IPv4, the limitation of the IPv4 addresses. To overcome the limitation of IPv4 address, IPv6 addresses has been launched. So hope you understand. This is all about the IPv4 addresses, or the IP address, why we use on our devices, and about the subnet max, why we use. Okay, so you can also see over here I have the 192.168 network, and this is my subnet max, and the gateway is here, and we'll talk about the gateway too also. Okay, this is just only about the IP subnet.